Hello, everybody. I'm Sudha Jamthe, and this is Weekly Wednesday at Business School of AI. And we started out recently doing this once a month where we do a live lab, which is something that we do as part of our courses here online, but we wanted to bring it to Weekly Wednesday. So I believe we did one on emotion AI sometime in June. So we're going to have a similar live lab this week, and it's even better than last time because we are just not going to show you data and discussion. And I try to be very agnostic and try to not bring any particular company or endorse any vendor, but I found this Playment platform for data labeling a very amazing intuitive UI. And Tanvi, who is our designer from Business School of AI, did an internship there and introduced us to the team. So I've invited Somana from there to show us a demo of the labeling platform. And it's not just going to be a demo of the platform, but he's going to be taking data that I've already set up for our live lab, and using that is going to show the data labeling platform and the whole the process. So why does it matter? What is the big deal about data labeling? Remember, we spoke about the AI confusion matrix. Anybody remembers what is in the AI confusion matrix? And for those of you who are new here, I am starting a recording. The recording will be available for you at Business School of AI under Weekly Wed, which is the course from where you signed up. And so if you don't want to be in the recording, turn off your videos, and there'll be people taking screenshots of and putting this on LinkedIn. Feel free to share because we are doing this for knowledge sharing. Okay. And one other thing I did in LinkedIn was I shared a picture and I asked about, let me share my screen. You will see what I'm talking about. I asked about this picture and I said, okay, this is the one we did with Emotion AI last lab. Think about, an AI building emotion, and it's going to be based on the expression of a face. And at that point, we were talking about will the AI look at Mona Lisa and say she's smiling? Now I'm thinking for the AI to be trained, the pictures need to be labeled. The training data needs to be labeled. How will you label this picture? What does that look like? How will you ensure the quality of that labeling? So yesterday on LinkedIn, I shared this picture and asked, what is special about this picture? Who took this picture? I shared this, so don't tell me it's me. Um, who took this picture, and is there anything special about these lanes? And you know the drill. If you're a regular here, use the chat to introduce yourself so that you can network with others, say which country you're coming from, and any question. And as we go through the interaction, you can ask a question, or you can refute something if you want, because we are very respectful of each other in this space, but we want to learn from each other. So if you have a different experience, we don't mind hearing something contrary to what we are teaching in here. Okay, so I see some chat. Let's see what people are saying. Okay, I'm seeing people saying where they're coming from. That's fantastic. Okay, Sweden, Bangalore, San Francisco Bay Area. Awesome. So any takers on who took this picture? It was not me. Yes. Yes. Yes, it was I wouldn't say an autonomous vehicle. It was definitely done by a car. A car camera is also fine. So yes, this was actually from the Tesla. I was trying to park the car, and right around that time, this is the view it saw of the road. So this is the front camera view from a Tesla. And what are these two lines? Are they lanes? What is it? The path of the car. Yeah. So when you're looking in a car and it gives you any kind of guidance, it actually draws the lane, and that's how the car stays within the lane. So coming back to our labeling project today, thank you everybody for your your chat input here. Yeah. Expected boundary of the vehicle is right. Yes, thank you, Emmanuel. So in this picture, you see a car, and we have done that in the AV masterclass, business of AV data course. Um, this is about object recognition, at least that's the minimum I would say. So it all starts with labeling, right? We've learned about variety of different labeling theoretically, but today I want you to go through an exercise of looking at labeling from what does it mean. So here we went through the ML life cycle, and in our AI ethics class we spent a lot of time on data collection. In fact, we did some lab exercise on doing this data collection right and making sure that we don't have bias and what kind of bias could be introduced in that exercise, right? So I want to go towards data labeling and understand that as a workflow. So quiz for you, and then I'm going to pass it on to Somana so you can see the real deal. So what percentage of time is spent on data labeling in the ML lifecycle? What do you think? What percentage of time is spent? We had done an exercise, I believe, in the AV data course about cost of data. And one of them was labeling the data. Do you remember? Guess is 40%, 40 to 50%. Okay, anybody else? Everybody's guessing 80%. Oh, wow, 280%, 240%, one more 50, 70. Okay, so what I'm going to do is I'm going to let the experts answer that question, and I'm going to have Somana talk to you about data labeling, show their amazing platform, and tell you what is real. And this is also, they work with a lot of different clients, and for data labeling, that's how they ended up deciding to create a platform on that. So I'm going to pass it on. And I said it's a lab, so this lab doesn't mean it's just a demo of a product here. So what we are going to do is I want you to do this with me. We can't do this live just now. So the way we are going to do this is I am actually going to propose a project. And once we learn this platform, Playment has magnanimously allowed us to, use their platform for our class projects. Up to 5 users, they allow it for free. So I would invite 4 people from here, and you can follow up and tell me in the chat towards the end whether you want to be one of those people, but you need to commit your time on this and do this with me. So what I've done is I've taken pictures from my DoorDash delivery. So we have an international crowd here. So I can't just say DoorDash. It is my delivery service, which actually gives me food, right? So they come and drop off food. So let me show you an image, what it looks like. And someone is going to use a lot more of this image, so you will see what I'm talking about. So let me share my screen and show you just this image. Do you see this? So they come and drop off food, and they came and left. In this case, they've dropped off grocery. I think this is from Instacart. There's a grocery box and cup, and then somebody has come and put some food delivery bags. There might be one bag, few bags. It might be kept differently. So I've got a bunch of these pictures. I think I have 50 plus picture, and I want to label this right, so that's the exercise today. And then I want to take that forward to actually do object recognition. So where can we identify the bags? And then, as I always say, it's never about just what the AI can do. It's about what business problem the AI can solve. So for the purpose of this lab, I'm saying object recognition, but we will develop this into a business question, translate that to what kind of model this is going to lead to, and then what kind of labeling, and then we'll go build a model. So that's the exercise we're going to go through. So we're going to focus on the labeling piece today. Okay. So with that, I am going to pass it on to Somana. And Somana comes from, I think, thank you Somana for joining us from India. It's late for you, I know. We have an international mix of people. We have people from Sweden. We have people from India. I saw Bay Area. Usually we have people from Nigeria and Canada. In fact, Today we have Olu, who's going to join us from Canada with an interesting announcement and opportunity in the second half today. Okay, and even within US, people are from various different parts of US. Um, with that, I am going to, and we have people from Brazil and Czech Republic, they'll be joining too. So with that, I'm going to pass it on to you. Somana, I just know that you're a customer success manager here at Playment, and you come from a sales background. Would you mind introducing yourself more holistically? Because one of the things we do here is we are hungry to learn what's real, what's happening in industry. So you bring that experience, but we are also very inspired by the career pivot people take. So everyone here typically works in industry or is kind of on their learning journey to continue to learn and pivot to AI or sometimes to autonomous vehicle, because those are topics we teach here. So we've been on this theme of learning pathway to AI for summer. So all our speakers, topics, labs, webinars is going to be on that. So it'll be inspiring to see, okay, you came from a sales background and then you moved to work in this amazing AI space with this company. So tell us a little bit about yourself, and then you can share your screen, and you have 30 minutes. I know we started a little late, but you'll have 30 minutes for your presentation. And people, you can chat away your questions, and if it makes sense, I might speak up and make sure that someone answers that. Somana, are you comfortable to just look at the chat, or do you want me to come in and read out the question? Because once you start sharing, you may not be able to see the chat well.
Yes, I think once I do start sharing, I might not be able to keep track with the chats.
Okay.
If they're
So
not
then I
meant.
can step in, I can come in and read out some of the questions. If it makes sense, I might ask the person to just speak the question. Otherwise, we typically keep that in a chat so that we are respectful of your time to optimize learning from you. Okay, so with that, I'm going to go off camera and I'm going to give you the stage. Here, I'll
Yeah,
pin you.
that's kind of it. So hi everyone. As Sudha mentioned, I work as a customer success manager at Playment. Now, to give you a bit more background about myself, um, I came from an academic background of learning about biology, biotechnology, and so on. And subsequently, I've worked for a few companies within sales, recruitment, and so on. Now, with Playment being in India, and also with just how much professional services work we do from India, um, I happened to join a company called Playment, where what we really do is on a day-to-day basis, just work with the machine learning teams at companies such as Samsung, Argo AI, Neuro, companies that are really at the forefront of computer vision research, companies that are developing our self-driving vehicles, self-driving delivery robots, self-driving or the robots in the factory. So we actively work with them. We help them with the training and validation data set that is required to bring their models to production. So part of this is done with our technology, and part of this is done with the help of our workforce. So today, what we have planned for you is maybe just a quick introduction to why data labeling in itself is such a huge challenge and at the same time a large opportunity, and also give you a preview of how um, you can label data for yourself if you are ever looking to build a machine learning model, a computer vision model, and show you how it can be done in terms of a platform. And 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 this, of course, does not have to be Playment's platform. There are numerous tools available in the market. I think we will also touch upon um, data annotation as a market, what tools are available as well. So with this, let me share my screen.
We had one of my students, I got Trident, works in NVIDIA, and he had come in as a speaker to show us about data labeling, just focused on lanes related to autonomous vehicles and the various challenges that um, that you face specifically with AVs. And for the purpose of this class, I want people to think beyond AVs. I know that's an exciting topic that I get to all the time. um, Computer vision, we are going to use that for any kind of IoT situations and healthcare situations where you're looking at X-rays. That's, it's computer vision. There's a lot of wide applications in with computer vision beyond robots and drones. So think about any image and see what the labeling is. And Soman, I hope you'll tell us the answer, whether what percentage of time is spent in the ML cycle.
Yes,
In Yeah.
coincidentally, that was a point that I would be touching upon.
Okay,
Uh,
thank you.
so, as I mentioned, at Playment, we really want to provide the best in class technology for data labeling because um, I think from the past 6 years, this is a challenge or problem that we are trying to solve. And the reason why we think this is very important is that among the uh, uh, production level machine learning or computer vision models that we see in the market today, 90% of them use supervised labeling, supervised learning. So this would mean that they would need labeled data, and they would need to be trained with this labeled data to be able to achieve or perform the desired task. Now, in that time that these companies, research organizations would spend to build the machine learning model, 80% of it is spent on data related tasks. A large chunk of it is spent on data cleaning, I believe somewhere around 25%, and a similar percent of it is spent just on data labeling. And when we look at specific industries, such as the one Sudha mentioned, the autonomous driving, the autonomous vehicle industry that we see is growing almost exponentially today, companies such as these just need huge amounts of data. And I'm sure most of you might be quite familiar with the standard saying that the quality of data is paramount to the success of the model. And when it comes to training data, it's more of a garbage in, garbage out approach. So quality and just the sheer amount of data that needs to be labeled is a very important challenge that needs to be solved, because when we are looking at data labeling at a scale, when we are talking about thousands of hours of videos that needs to be annotated, it is not a simple question um, of hiring a few annotators, giving them the platform, and telling them what to do. At an operation of this scale, every second, every error can add up, and we really need to ensure that there is a highly optimized and automated process with which you can address some of these operational challenges. Because at the end of the day, if you need labeled data, this ground truth would need to be built by humans. And whenever we deal with humans, there is always a probability of error. So, Playment as an organization, we've really been trying to focus on this problem statement. How do we take this complex, large problem such as data labeling, break it down into manageable and simpler chunks so that we reduce the probability of error, um, we ensure that the task is being completed at maximum efficiency, so that at the end of the day, our vision of trying to accelerate the age of AI, trying to accelerate the development and deployment of machine learning models can be achieved. Now, coming to the actual type of annotation and the the reality of how this really happens. Now, depending upon the kind of model that you're working with, the kind of data sets that you're working with, and what you're hoping your computer vision model can do, you would decide on specific types of annotation based on some of these parameters. Just as an example, um, if we are if we are looking to identify people, detect them across frames, and track them across a particular sequence of frames or across a video, then a simple bounding box annotation might be sufficient. But as Sudha mentioned, If, for example, we are looking for a lot more granular detail, if we are looking to perform facial recognition, and also perhaps sentiment analysis, then not only do we need to tell one face apart from another, but we would also need to teach our model um, what the right eye, face, and nose alignment would look like when a person is happy, when a person is sad, um, and when they're smiling or crying, for example. So the goal with or the goal with our annotation platform, or rather what you'd find with our annotation platform, is one solution where you would be able to create multiple projects that might require different types of annotation, depending upon the kind of business solution that you might be working on. Um, you might need different annotation types yourself. So this way, it becomes easy for you to just have all of your annotation in a centralized place. And I think when we talk about the larger picture as well, as you scale up your models, as you move them towards production, you would be just dealing with just just huge amounts of data, and you would need a systematic and centralized uh, tool with which you can manage all of this. And that is where really data annotation platforms really become key to how you would be the key to success of your data of sorry, the key to success of your whole ML process. Because at the end of the day, you are going to be spending a lot of time on data annotation, and if it is not done efficiently, there'll just be losses in terms of time and revenue. Um, so based on this, we generally support different types of data as well. The machine learning model that you are building could be working um, with audio waves such as radar, could be working with text, or they could be working with vision related tasks. And within the specific realm of vision, we have 2D sensors such as image, videos, and we have the increasing use of 3D sensors. I think as an organization, we've just seen tremendous implementation of LiDAR in in areas such as um, obviously I think the autonomous driving space, but also the drones in industries such as construction, and in fact even the healthcare industry as well. Um, so all of these types of annotation, you can pretty much decide how the data needs to be labeled. You would, of course, need to decide on a uniform labeling guidelines based on how just the data labeling works. And then you would be able to use an annotation tool to just perform the data labeling. But one key aspect of all of this is that we need to consider the scale at which data labeling happens. Um, as we look at more data, it is not just humans all by themselves that can achieve a reasonable amount of turnaround time that can make it profitable and feasible for you to build and deploy production level machine learning models. And that is really where um, you know we use a combination of software along with human intelligence to achieve the best speed possible without compromising on the quality. So I will touch upon all of these aspects, such as the ML models that we use to perform certain level of automated labeling. Because at the end of the day, even for yourself, let's say if you're looking to build a home security system, you would not need to reinvent the wheel uh, when it comes to detecting people in the house, when it comes to maybe detecting certain events like a fire breaking out. There might already be models available, and an annotation platform is just one way to use this model along with human intelligence so that you can further customize the data to your needs. So I will be touching upon how we use a combination of humans and automated software-driven tools in order to not just speed up the process, but also achieve the kind of quality that these production level pipelines require. Because at the end of the day, some of these models have huge repercussions or um, safety standards and guidelines that they need to meet. And the key way of doing that is with making sure that the training data that we feed into it um, is at least well defined in terms of the quality. Now, what I'd like to do is just walk you through our platform, give you some idea about how you might be able to one day sign up and do all of this yourself. But before that, do we have any questions about um, Playment as an organization, how we look at data labeling, the kind of workforce and the kind of um, I think the one aspect that we did not really touch upon is there's a sheer amount of people who today are involved with data labeling, um, considering this amount of data that needs to be labeled and considering just the need for humans in this, the irreplaceable need, I would say, for humans in this process.
So there's a term called data programming that we keep hearing about data labeling. So, 80%, as you mentioned, in the ML cycle is about organizing data, but just, getting the data ready for labeling and then deciding whether, is it outsourcing to somebody or is it here? There's a human in the loop. What does that look like? You know, I heard there's like tools that help in the process. Maybe as you start to jump into the demo, you might show us how you're doing the dual approach.
Absolutely. Or rather, I think it would be best to slightly touch upon this now because what we generally see on a case-to-case basis, dealing with customers who are at various stages of the development of their ML models, that the need for a high throughput outsourced annotation, such as the kind of services that we really provide, comes in when you start taking your ML models closer towards production. At an initial stage, you would generally find that the individuals who are building the ML models, the kind of effort that customers spend and how they prefer to get this done is at the initial stages, the computer vision engineers themselves, or in your case, the person building the model, the person most familiar with what their input data would look like, and the person who best understands what is the desired output. So, for example, if you are a doctor uh, and if you are trying to write a model to differentiate and automatically detect certain types of cells, then based on the kind of data set that you are looking at, initially you would start labeling the data yourself, um, and then based on this, you can achieve certain model, a certain uh, the alpha or beta version of the model. And at this point, we generally see that it is still better to have the data labeling under very close control because of a couple of reasons. Your data labeling guidelines will always change based on certain new challenges that you face as you're scaling up. Your business goals might change based on the customer, um, the the response that you get from your customers. So based on this, your guidelines could always change. The way that you label and process the data could always change at very short notice. So having an internal data labeling team is very helpful and at the same time quite convenient in this day and age because we have platforms that just you can sign up and talk to a few um, freelance annotators and just you can have them get started within a moment's notice. But as we look at this at scale, as we look at businesses where data quality, data security, these things become very important. In such cases, it makes perfect sense to to outsource this entire project to a company that really specializes in data annotation. So this whole industry with data annotation is exceedingly large. You would find a lot of help when it comes to not just data labeling, but also data collection. Um, and based on your life cycle, there are plenty of options available with um, just doing it yourself and with getting external help from vendors or partners such as ourselves. So coming back to the platform, and if there are any other questions, feel free to stop me as well. But coming to the platform, what I first try to do is take the example that Sudha had mentioned earlier and just showcase how different types of annotation can happen based on just your business approach in terms of what model you're looking to build and what you're trying to automate or achieve with it. So this is just our data annotation platform. As mentioned, this is really a platform where we really want to, it's not just a platform that focuses on the act of creating annotations, but rather we try to address the operational challenge of managing data from multiple projects, managing hundreds and thousands of users. So that whole project management side of things. But just to make it easier, I'll show you quickly how this basic project is set up. So you would just create, you would decide what type of annotation it is. If you're looking to track objects, you might be dealing with videos. If you're looking for a very fine pixel level annotation, it might be segmentation. Or in this case, we are dealing with image as a sensor type. So you will just have to select image. And as mentioned earlier, we do have projects where we uh, which use 3D. So these would be LiDAR sensors where the output is seen as a point cloud. And we have sensor fusion of these tools along with the cameras that are capturing just the video feed. So if time permits, I will try to showcase how one of these 3D data sets would also look like. Now, the first thing about your data annotation project is you need to decide what needs to be labeled and how it needs to be labeled. And this will be defined by the business use case. In this case, we are trying to look at a scenario where um, we have customers we have users, delivery executives who upload images of your door with the package placed in front of it. Now, just off the top of my head, you could try and automate certain things, so you can automate whether the delivery executive is just uploading a random image, or you could build a computer vision model that analyzes the image and it recognizes the image as being um, as a relevant one, where we are looking at the parcel or the package being placed in front of the door and not just some random image of a shop front, for example. So part of this would be to define the specifications. Now, based on the image that I had showcased earlier, I had shown different annotation types, bounding boxes, key points. So you would decide what type of annotation, how the labels need to be created. You would define the metadata, right? So when we are looking at the package, is the package damaged? Is it are there multiple packages? So any metadata that you want to collect about your data type. So for example, if you are looking at cells, um, you can have further sub information about the cell. Does it look cancerous? Does it seem to be at a nascent stage, early stage? So that kind of data you need to configure, and this is simply done by just configuring your annotation specification. After that is really how you decide how the data is labeled. So you just
Sorry, Samana, I just want to jump in. Um, we did this exercise of image from a camera from facial recognition at the entry of a mall showing whether a person is wearing a mask or not. So your attribute, so the when you at this stage you're just going to say this is a face, or maybe you're going to go granular and say this is a nose and eyes, but that's the labeling part you're doing, right? But the attribute could be whether the mask is worn right. So it might identify the person wearing a mask, but if they're wearing the mask below their nose, that's not good. So there's public data set with this kind of annotation, which is mask worn well or not. And then your labeling attribute will define that already. That's how it will know whether it's good or bad. I just
Absolutely.
wanted, yeah, thank you.
I think, and to show you how this looks and feels in the front end, now, this is the wrong task.
Your platform is very powerful, so we're not doing justice to it by one demo, but I wanted to see whether taking this image set and going through that exercise, at least the class can appreciate the complexity involved in labeling.
Yeah, I think so with the platform, why it really matters to us is because just at the scale of operation that we look at, if we can even save one click or a second from every task or from the task of annotating every image, that significantly adds up for us just in terms of an operational improvement. So that is why I think the whole industry around data labeling um, has been growing at the way that it is, and why there is just so much money being invested in this area. Um, so 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 if you look at examples such as this, you might be working on a use case where you automate the validation of these images as a delivery executive uploads them. You have a computer vision model to verify whether this is a relevant image, whether there is really a parcel kept safely and correctly in front of a door. Um, so based on this, sorry, was there a question? So based on this, I have already configured the class list of classes or the objects that are important to me. So I can now draw a bounding box around all the doors in the images that we see to teach my model what a door looks like. So the next time there's a parcel in front of just a wall, it can say that okay, it's not really in front of a door. So I select the class, and now let's say as part of my project, if there are certain important flags that I'm looking out for. Let's say that this door is not really a door. It looks like maybe the the gate of a business establishment and not really a private residence. I could check if it's unconfirmed. If the door is already open, that might be a red flag. Or in this case, I just select no red flags. So this whole process where you see that I draw a box, I would then select the label, and then from the label, I now start adding the metadata. So this whole process, I think from our end, we've tried to design it in the most optimal manner so that when we are looking at thousands and thousands of images at a day, uh, we can save every second possible, placed correctly. So this image is now correctly annotated. I submit it. So we have large chunks of data. And from the point of view, and what you're seeing really is what thousands of people do on a day-to-day basis. They form a key element in a large pipeline where uh, their intelligence is used to train these models and automate so much tasks that either is sometimes is too injurious for a human to do, sometimes it's just more profitable for a human to do, things like that. So an annotator, they will go through all of these image one by one, and just and since the project is already configured, they would just go through it in a very efficient manner without in a very guided manner. so that there's very less chance of an error. Now, this is one example where we are drawing annotations, where we are drawing the labels in the image, where we're teaching the label, the model that, okay, within these boundaries is the door, within these boundaries is the package. In a lot of cases, you might not even need to draw any labels at all. For example, you might be working on a model to help you differentiate between uh, two types of animals, for example, a dog and a cat, and a simple classification would be enough of these images. So, in a more kind of an environment that we see, uh, autonomous driving vehicles collect thousands and thousands of hours of video. uh, they would first perform something of a frame classification where they look through all the data, identify frames where there are certain objects of interest. It might be a street light, it might be a tunnel, it might be a certain road sign, and then they would perform further annotation on this. So, so this type of a classification exercise as well, if that is what the project requires, can just as easily be set up. And in this case, all I need to do is I don't have to draw any labels. I just go through each image. And this is really what I think part of the DoorDash team also would be doing. They would sort of be validating each image. Okay, is there a door? Is there a package in front of the door? No, there's no package. And what's the problem? Package is not visible. Is there any other issues? Well, in this case, I don't have to put none, but yes. So this way, I can get through images at a much faster rate without wasting any time, uh, without spending any time on drawing the actual annotations themselves. So this is specifically with regards to this example, how in terms of the DoorDash example, how some of the annotation scenarios could play out. But let's say that you want to build a model to recognize the door itself, and you want to verify if this door belongs to a certain person. So in such cases, you would need to provide a lot more granular information about each and every door, and that can be more easily accomplished with a kind of pixel-wise annotation that is possible with semantic segmentation. So instead of your example, I took up a general example image just to show you how the kind of advancements that has happened just within the realm of data annotation when it comes to labeling data. Because uh, when we deal with such objects such as people and vehicles, taking a polygon and drawing a careful outline around this car would be hard. Rather, what uh, what the industry has been working towards is a combination of ML models along with human intelligence that can really be used to sort of hyper speed or get that high performance out of just when compared to manual annotation. So if I want to label this car, all I need to do is draw 4 points at 4 extreme corners. Its topmost point, bottommost point, right and leftmost point, and hit enter. And then we have a software that is already been trained on data sets that, you know, on data sets. So it can recognize certain types of objects and reduce the amount of human labor involved. But at the same time, it's important for us to have the human in the center so that we see here a very small section of orange that has been missed. So I can always fix these errors and make sure that the final annotation quality is not hampered by the uh, quality of the AI models that are being used to help with your annotation. Because in the end, we want ground truth, and our the work that we try and do, the tools that we try and build, help in terms of just getting as close as possible to that 100% accuracy. But then again, I think a point that your team might have discussed already is just how important quality is and how it becomes a challenge to accurately measure this quality as well. So a part of this question, a part of this problem is just in terms of looking at the annotations after it has been done without any bias, and then performing a very systematic evaluation of all of the annotation so that you can um, you can without any bias say that okay, I'm dealing with data that is 95% accuracy or 95% precision and recall. In the end you would need a standardized process to define all of this. So that is also an area where um, we have a combination of software as well as human intelligence that play a vital role. Now, just as an example, um, when we are annotating vehicles or humans, we have a general idea about the dimensions of these objects. So I can set specific rules um, which say that, for example, if I'm annotating a vehicle, its maximum and minimum dimension of the annotation that I'm using to capture this vehicle should be between so and so. Um, so there are various ways in which we can incorporate software to place this. One simple way. So, as an example, now I think just detecting when people go into sleep, just capturing the attention of the driver. This is a huge use case that the industry is working on. And key part of this is in capturing the just the granular details of how the eyes are open, closed, glint, and so on. So here, as we mentioned earlier, you can create class like in a bounding box. I can create one class for the entire face, but then at a more granular level, you can also use key points to, for example, define the boundary of the lips, the contour of the nose, or the eye lines. Now, in this case, let me just draw four random points as we see in this example. And automatically, I'm instructed by the software that these points should be placed in a perpendicular manner, in a manner that is seen here. So we have these perpendicular points that are working with each other and not points that are placed adjacent to each other in the way that I have done. So this is one way in which we can place software uh, to control the quality at the creation stage itself. But just as key is how we use humans as control steps themselves. So, for example,
So I want to just add one more thing before you add the human in the loop. Can you go back to that picture, please?
the picture of the eye.
The eye.
Yeah.
Because you're working on this day in, day out with so many different client situations. So uh, when you say data quality metrics, you know what you're talking about. I just wanted to add something for context to the class. So we did this exercise on data bias in our AI ethics class. And one of the, especially, and with the lab with the emotions AI also. So labeling a human face, it calls for bias, right? There are 53 kinds of bias that we covered, Susanna Raj covered. And an eye saying, okay, this person is awake, alert, is not just a data problem. It is also about bias mitigation problem. So defining the I and how to say that this person is awake and alert, the definition of it right at the labeling stage would bring in the bias, cultural bias, different kind of faces, different kind of race of people involved in the data set. So I just want to call that out. So, and looks like you're actually having a some kind of software augmentation that actually is making sure that is also done right. So your software could ensure that there is less bias. So if the face of a person is of Indian descent or Chinese descent or something different, then you'll make sure that all of that is included. So when it makes the recommendation of how to label the eye, that could be baked in. So bias mitigation could be part of your platform. So thank you.
Absolutely, and I think it's vital to look at it from the project planning perspective itself. because with the software it's easy to do. As we look at, for example, if you're looking to build any model that is important to look at human faces, for the software you can easily build tools that tell you, okay, the face I'm looking at, what kind of ethnicity is that, and then we can always ensure that the all the ethnicities are represented equally among the data set. But um, but I think it's important to plan ahead, just in terms of making sure that your data set is encompassing, so that planning for how the data labeling would actually happen is a very key part of the process. Because once you put a process and a set process in motion, it becomes costly to go back and then correct it. So rather, I think planning for these projects as your data needs increase, just deciding on how the data needs to be labeled, what the guidelines are, how the collection needs to be done. This is a key part of the process, I think, just from a whole
This is
ML.
good. I mean, we are reaching the end of our hour already here, and there are some questions and comments. Having Ankit in the chat has been helpful. He's been answering some questions, so that's taken care of. Uh, I just wanted to see whether you needed to say anything to wrap up, so that I want to make sure that we close the class properly.
Yes, unfortunately, I think I completely lost track of time. Data annotation, I think, was in recent times has been a very passionate subject for me. Just looking at the just some of the unique and brilliant computer vision models that are being built in the industry is just a pleasure. I'm sure that people from this team, I think, will be coming up with more of them. So really looking forward to it. This whole platform, I know we didn't really cover all of it, but there's a lot of information on our blog in terms of how to measure quality, how to decide whether you're spending the right amount of data labeling. So there's plenty of information available, and uh, that you can always use
Yep.
in your ML journey.
Okay. Thank you so much, Samana. So
Thank you, Sudha.
before we wrap up, I was hoping to do a little bit more. Can you stop sharing your screen if you don't mind? Thank you so much. This was really helpful. So for those of you who came in late, I need to go back on video only, then you can see me. So I hope that gives you a good idea of, data labeling, how that is, is you can introduce bias, you can eliminate bias, you can automate things, you can bring AI to do the labeling, but it's just not a Boolean. You have to have the human in the loop. There's a lot more in here. So part of our exercise is to take this DoorDash, Instacart data that I have. If you want, you can bring in your data. I'm going to take 4 people. So ping me here, you can follow up. I'm going to take 4 people to work with me on this project, and we're going to go through this whole data labeling, bias mitigation, setting the right metrics for data quality, and go from there, and then we are going to go build out the computer vision model. That's what I'm going for, and I would love for you to work with me on that. So we have Olu here. She has an exciting announcement, so I want to see whether we can just give her a minute before we wrap up. And as always, I will be sharing this recording, and I have a quiz for the class. So you have learned about AI confusion matrix with precision and recall. So what would the precision and recall be? What would your data quality metric be when you're doing labeling? So if you're just doing labeling, but you want to ensure that there's a certain precision and certain recall, what would that look like? So let me remind you what is the confusion matrix. Just a minute. Then we will pass it to Olu, and then we'll wrap up. Okay. And if you want to drop off, you can. I'm going to be speaking at Olu's storytellers event tomorrow. So here is AI confusion matrix, which is false positive, false negative. So every time you run a model, you're going to get those, right? False positive and false negatives. So recall is how often is it saying yes. That is the true positive by true positive or false negative. And then how much time is it really accurate when it is doing this? So a version of this is usually built using the annotation. And let me share you that screen. what that looks like. And even the Playment people have that, but I just, yeah, I think we did not have enough time, given that it's a huge topic, but I hope you got the appreciation of how huge a topic it is, for data labeling. So the precision and recall, when you look at this using data labeling, is when you say, instead of saying true positive plus true negative by the total for defining accuracy, you could say the objects correctly annotated plus objects not correctly annotated, assuming labeling is the only problem, not model hypertuning or any issues involved in defining accuracy. You could set metrics based on the labels itself, and that is something that's typically done in the data labeling universe. So with that, remember to connect with me and tell me if something you're going to work, if you're interested in working on a project. I'm going to take only 4 people to work with me on this DoorDash exercise, and if there's a new team forming and both more of you want to work on it, talk to me. I'm going to pass it on to Olu. Hi Olu, thank you for joining us.
Thank you,
tell
Sudha.
us your Tell us
Yeah.
about your storyteller series, and
Okay. Thank you so much. Thank you, everyone, for giving me the opportunity. Thank you, Sudha. So, Storytellers with Olunaya Speaks is a storytellers platform and network and community for entrepreneurs, for innovators, for dreamers to share their stories, as well as equip dreamers to innovate, future innovators. So we have different entrepreneurs, different business professionals from diverse industries that come to share their stories, where we can connect and then equip the future, what we call the future dreamers, future innovators, as we begin to, innovate for the future post COVID. So we're going to host Sudha. She's going to take us through AI, IoT, data science, and all the whole 9 yards of what you guys talk about for novices like me, other entrepreneurs who want to go into that space, but they feel that it's reserved for a certain class of people. But we want to, unveil all of that as Sudha takes us through the learning journey into that beautiful and intriguing world that you guys, you've been talking about. So please join us. It's at 1 p.m. Eastern time to 2 o'clock, where Sudha, just to support Sudha and also support, this beautiful work that you guys are doing. Thank you. Back to you, Sudha.
where can people join you? Where's the
What?
link for that? Where can people join the
Yes.
storytellers? And
Okay.
beyond, other than me, so tomorrow I'm speaking at 10 o'clock here.
Yeah, tomorrow she's speaking 1 p.m. Eastern time.
Okay.
Yes, and the can I post the link to
Yes.
you here?
Yes. Yeah.
Okay,
And
just
I will make sure that we share it when we send out the recording link back to people, or just
okay.
to send it back.
Okay, what
We'll
do you want me to do now? Do you want me to send it here now?
No, you can post it here. You can post it here so people can get it if
Okay,
they are
okay,
interested.
that's excellent. Yeah, I'll just post it straight up. Thank you so much. And
And do you do this every week, or
yeah,
what is
it's
it?
bi-monthly. So after Suda, we're having the next one on the 29th, and it's different industries. 3 sessions. We've had business aviation, we've had illustrators, animators, we've talked about global culture. So we're going to go into other things. Entrepreneurship, we'll look at mentoring, we'll look at communication, different industries, as a way to equip entrepreneurs for the future, and for what they're innovating. So here comes the link, and just a second.
And it's free to join, right? So
Oh
10
yes,
o'clock.
it's free to join. Yeah,
Okay.
it's free to join, and you can, yeah, and that's the link. Thank
Okay, so you're giving us the direct Zoom link. Okay, I will post
Yes,
this.
yes,
Post
thank
this out on public. But I
yes.
will share. So each time you'll have a
And
new Zoom. You can come back
yeah,
and
yeah,
tell us.
yeah, yeah. Each time there's a new Zoom link, and then you can follow the stories that have been shared in times past, and I will just share my LinkedIn post. Just you'll find that everything on
Okay.
my post. Yeah, thank you so
Okay.
much.
So thank you so much,
Thank you,
Olu. This
Sudha.
was fantastic. Last time I got a glimpse of the aviation speaker. It was It was
it was
very different.
awesome.
And
Yeah, it
and the
was.
reason, yeah, so go ahead. Yeah.
No, no, go ahead, please.
So the reason I invited you is because there are so many online events going on, but I've never seen that kind of energy. Like, I'm very proud of this group here, and we are very international mix of people. But I saw that there was so much interaction, and people who are especially career pivoting, moving to new space, can learn from your storyteller series. So the
Thank
easiest
you.
thing is to just follow you on LinkedIn, and you keep posting the recording and new
Mm-hmm.
events as they come. So
Yes.
with that, I'm going to wrap up. Thank you
Thank you.
so much.
Thank you.
Thank you. Yeah. Thank you, everybody. We will have the recording of this session and at Weekly Wed, if you're already signed up, and you'll get a notification when it's ready also. And with that, I'm going to wrap up. And if there, this topic we just started new, so we will be continuing. So give us feedback, what you like, what you didn't like, what we could change. We take that seriously. And then remember, I'm going to take 4 people to work with me on this. I have a lot of different projects like that I work. So as I get ready for every class, I play with new technologies. And the way I do that is I create projects to go through the whole exercise. So in the end, you will end up learning labeling, but you'll also end up, building out a computer vision model is what I'm going for. So that is one. I have a bunch of journals and papers and research stuff that I do. Of course, I write blogs, you've seen. So I thought I would invite some of my students, some of you here at Weekly Wednesday to work with me so that we could, do this more interactively. So this is my first exercise of doing that. So ping me, and I have not figured out what exactly is my criteria. I will try to be unbiased, but I tend to be biased towards my students. But hopefully I'll be able to work with 4 of you on that. Or if more people show up, maybe we can go to Playment and get more seats so that we can have multiple teams. But I want you to learn this whole labeling exercise and get to a deeper understanding of computer vision. So that's my goal here. Thank you, everybody. With that, I'm going to wrap up, and stay safe and have a fantastic rest of the week. And some of you, if you're joining Olu Storytellers, maybe I'll see you online tomorrow, and the Zoom link is in the chat. um, what else do we have? We have a bunch. This, I think, Transform 2021 Venture Beats conference is going on. I'm doing a small 15 minutes. It's called Sudha Live. I'm sorry, sounding a very presumptuous name. I do like a YouTube live stream at 6 p.m. on Friday, like 6 p.m. my time. So it might not make sense for Europe, and it's too early for India, but more into Asia, maybe you will have access to that. So I'm doing this 15 minutes to just say what are the opportunities, not just limited to my courses are offering, but what am I seeing out there, to kind of sift through that, to share that with you on this theme of learning pathway to AI. I've been sharing that on YouTube. So if you follow me on YouTube, obviously you'll get the notification. Otherwise, I share that on LinkedIn. You can follow our Business School of AI on LinkedIn. And then, I forgot the recording from this session. I'm going to do a blog around it and share the recording at Business School of AI on Medium. So medium.com/Business School of AI. If you follow that blog, you will get the blog with a summary of each week's whatever we are doing in Weekly Wednesday, and with the recording. So if you don't want to sign up anywhere else, just follow us on Medium, and you don't need to give us email or anything else, and you can just come read, watch the video, and then go from there. So with that, I'm going to wrap up, but be sure to connect with other people here, because we have an amazing set of people from all around the world, equally hungry in various stages of success and in the transition to AI, and doing amazing things in there. So with that, I'm going to wrap up. Thank you, everybody. Stay safe, and see you next week.